giving. If you're half as tired as I am, what you want is a nice comfy chair and get off your feet. So the fact that you actually are here for the last talk of the last day of a pretty hectic, crazy conference, thank you very much. I appreciate that. This talk is actually not about data centers. Data centers come in various shapes and sizes, ranging from customized modular systems to these big behemoths that, like that's the Yahoo chicken coop on the right there. You know, all kinds of shapes and sizes. We have them in a few shapes and sizes as well. I'm actually more interested in something like this, which is a virtualized system where the data center doesn't really exist. You have no walls to think about. You don't have to worry about what's going to happen when I run out of physical space. That is our headache, but you, as a user, do not need to worry about that. So you've heard a million things over the last few days about running at scale, running efficiently at reInvent. I think every single Netflix talk that I've seen on availability, et cetera, has had lines so long that I haven't even bothered to walk in. And if it feels like a bit of drinking through the fire hose, I think it is. Just in the few sessions that I've sat, customer talks have been awesome. So what I'd like to do is ask you to imagine. You know, I'm a product manager on EC2. I spend a lot of my time thinking about servers and instances and how to scale it and how to build infrastructure that people can use elastically. What I'd like you to imagine is a world that I lived in a long time ago. Let's call this company, let's say you're in a company called NewCo. It's a small startup. It's a small biotech company. I actually worked at one. But it doesn't really matter. It could be a new business unit at a larger company. It could be any type of company. This company makes compounds. For those of you who don't care about science, ignore me, but essentially the goal of this company is not compounds, it's to predict function in proteins. So you look at a protein structure, try and identify its chemistry, and then say, okay, if I could fit something in here, we believe this is what this protein does, and then we can try and make it not do that. So if this protein is implicated in some disease like diabetes, we can try and inhibit it as long as we understand what the functional chemistry is. So there's a lot of computational modeling you have to do, a lot of analysis you have to do. You need a lot of compute. In the end, you have to try and figure out what it is, and you can make pretty pictures of proteins. They look good, but the ultimate use is to try and build drugs. So we did what everybody else, in fact, this is back at the turn of the century, we bought a rack of computers. Actually bought a little small cluster of computers, put it in a room. I used to sit next to it. We had multiple groups that needed access to this cluster. I happened to be in a room that did algorithmic work. There's another team that did informatics work, and there's the downstream analysis people who took the results that came out of the first two teams and wanted to do further validation work. So all of us wanted to go at these clusters. So you run into the same problem that everybody else does. We wanted to get more servers. There was only one problem. We didn't have any space. The room was full. I think if I'd wanted to walk into it, other than to change a few disks, it might have been difficult. It got really hot. The one problem we definitely had was this was in a small company in San Diego in a small building. We had no way of getting more power to that building, so you had to worry about that. And we had a lot of risk. We were a little startup. We were just at Series A or Series B. What happens if our startup fails? Or if you're a larger company, I used to work at Merck before I came to Amazon. One of the biggest challenges was starting projects that could be capital intensive and then completely collapse, and that was a ton of money required given the computational requirements. So there was risk involved. You might need to spend a lot of capital, and depending on where you are, you might be a little loath to do that. So what do? Everybody got put into a queue, which meant that very often you sat there waiting for your turn to start because somebody else was prioritized above you. The algorithm guys wanted more time. And then this big project comes along, and you might say it's a good problem to have. You're getting more money. But what it really means is one team or more are getting blocked. They are severely constrained in what they're trying to achieve, in trying to get work done, or maybe they have to work. Let's say we are building these models for function of proteins. We can't build them for 3 months because we have this other project, so we just have to crunch on the data that we have. So it's very common. You've heard this many, many times at this conference. You tend to run into a brick wall. This brick wall, I've heard it from enterprises, I've heard it from startups, is, okay, what do I do next? How do I function? So Regardless of what size of data center you live in, this is true even at Amazon, at some point of time, the data center is going to get too small. When I started at AWS, we used to have 3 availability zones. Now we have multiple availability zones and over 10 data centers in US East. So obviously, you have to keep expanding. So, and a data center, in some ways, is a constraint. It has physical walls, and walls do not move. I think that's where the cloud comes in. But the way you think about server capacity, instance capacity, compute capacity in the cloud changes from the way you would think about it if you were trying to put your racks in a colo, if you're trying to build your own data center and strap them there, or if you're in a small startup like I was and ran out of physical space. We were actually trying to figure out if we should go find another colo provider, move into a new building, et cetera, and which, given the small size of the company, was a huge problem. So the change that happens is most people think about capacity in terms of, oh, I need so much CPU, I need memory, I need this, network, power, and cooling. Every data center has stuff like that inside. But once you deconstruct it into its components, it's CPU, memory, disk, network, power, and cooling. Let's take power and cooling out of the way, because that's not something you worry about. What Amazon EC2 provides you is, as instances, CPU, memory, disk, and networking. Power and cooling part you don't have to worry about at all. So the way to think about it is, the most important asset you have are your people. You want to not block your bioinformaticians. You don't want to block a business unit. You want to remove these constraints. As a friend of mine once said, you mean to say I can start a project on a whim? I think that's the key. If you have an interesting idea, you heard Jeff this morning, you want to be able to experiment as many times as possible and not let the physical bounds of the walls of your data center, however big it is, or whether it's a colo or a managed facility, whatever it is, come in the way. So you embrace change and make your end users pretty happy. How do you do that? So you're no longer constrained by space, power and cooling, capital. And this is the part that I really wanted to spend time on, which is these agents of this change. The first one is on-demand computing. I think that's not surprising to anybody. What it means is when you request a server, you get it. You don't have to figure out how do you provision your next tranche 6 months ahead of time, because that's how long your cycles are. Or if you're a really well-functioning company, 6 to 8 weeks ahead of time. Most aren't. And if there's not one available to you, know right away. So that's the advantage of on-demand computing. So the idea is for when you need it and for whom you need. So if one particular group needs computing for a short period of time, you don't have to scratch your heads trying to figure out what's the most efficient way of doing it. You can make it available to them. So in this particular scenario, you have all of these guys in a queue. You can give these guys who use the most computing. You can give these guys their own rack. You can give the informatics team its own rack. And you can go ahead and give the analysis team its own rack as well. Most likely, they'll be like this. One team needs a full rack's worth of instances. The other team needs a little tiny sliver of capacity. You don't have to compete for resources. And these are the guys who get left behind every time because the other teams need it more. And then there's this third team that can get its own size of capacity. I'm showing racks there, but think of them in terms of instances, which are essentially just an API call away. You can do that, and it's phenomenally interesting. I think the biggest difference between thinking about overall capacity is, okay, how do I chunk it up? You can actually distill it down to the project. We've seen many customers. Adrian Cockcroft from Netflix was talking about it earlier today. If they buy a lot of reserved instances and they give these to various teams, and if there's any capacity left over, they use it for work that they may not normally do otherwise, like some backlog that they have to process. So you can do things pretty interestingly once you can decide, hey, each team gets its own set of capacity. I don't have to worry about when, how, and then the question becomes this, let's make sure that the cost allocation is working right. The second part is elasticity. We talked about starting from a baseline where each group has got its own little sweet set of resources. They're not encroaching on each other's territory, and that's fine. Let's take this group. They have a ton of work, and this big project suddenly comes along. You can give them another rack's worth of capacity, give them another 40 to 150 instances, or give them a third one. And the best part is if they ever wanted to go down, the project's over, and they wanted to go back to steady state, that's a no-brainer. Again, the way you think about it from a capacity planning perspective is figure out what resources you need as a baseline, and then when you need more resources, add them for the time you need them, get away from it. It's much easier thinking in terms of capacity that you need for a chunk of time where you're trying to figure out exactly how much you need for the new work, then try and predict upfront Oh, 6 months down the line, I might have this big project, and for that project, for about 3 months, I'll need 2 racks more of compute capacity. It just doesn't work. You just plan your projects differently when you have planning available to you. And you can rinse and repeat this. You can go from 1 rack, from 50 instances to 100 to 300, and do it as many times as you have projects. You can do it independently for each team. The capacity planning becomes a team-level exercise, not a big infrastructure management organization level exercise, which is a huge problem at a lot of companies when you're trying to scale. Surprise, surprise, the standard Animoto graph. This would not be possible in a world where you didn't have this capability. The other time I used to hate this graph because I'd seen it so often. The third part is flexibility. And I think if you take the previous two and combine them with this one, it makes it particularly powerful. And what flexibility means is choosing the right instance type. Let's go back to our small company. We had 3 teams with different types of resource requirements. They had different types of computation to do, but we had one homogeneous cluster. We bought it from IBM, stood in a few racks in our data center, and that's all we had, and we had to fit our job into it. But EC2 gives you multiple instance types. So it's not just for when you need and for whom you need, but it's also what you need. Hey, you have a memory-intensive job, you can run a memory-intensive instance. You have a compute-intensive job, you can run a compute-intensive instance. Today, we have all these different instance types. We announced 2 today, the cluster high memory and the high storage. They're not quite available yet, but will be shortly. And each of them has been optimized for a different task. So if you have kind of work that I used to do, you probably want to end up on the cluster compute instance where you are running MPI applications, running big simulations, and you're fine. But if you have bioinformatics group, you're most likely running scalable, just loosely coupled scale-out applications, and you're very happy with the high CPU instances. And you could be a database group that wants to do warehousing, and you can go into the new high storage instances. Each has a purpose. You do not have to figure out. You can actually experiment and figure out what works best for you, what's the lowest cost. You have all those options. So from a user standpoint, I think the key part to remember is you can choose the right price. Let's continue, actually, come back to that point. So you've chosen your instance type. You've figured out which teams need access to these instances. So let's we go back to our 3 teams. Each of them has some capacity. Each of them has a steady state of a particular amount of capacity. So how much are you willing to pay for them? And what is the utilization? The first thing to think about is reserved instances. Let's say you find that those 3 racks that you have, one team is using all of the 50 instances. One team's always using 20, and one team's always using about 40. You've been running them for a while, and you've figured out that this is our baseline. You can purchase all of them as reserved instances, and you don't have to restart any instance. They automatically switch over to paying the lower price that reserved instances give you. And the thing to remember is reserved instances aren't just a low price. They actually make sure that every time you ask for that instance, you will always get it. We don't quite call them capacity guarantees, but essentially they are. You're guaranteeing that every time you request that instance, there's no way that you will not get it. We give you 3 types. So let's say one team is using the resources all the time. They would be better off using up a heavy utilization reserved instance. If one team is using its resources some of the time, let's say 50, 60%, they're probably better off using medium utilization. And one team is just doing it in bursts of capacity, probably 25, 30% of the time, using light. My personal experience is that most users fit into the light and the heavy. The medium is what we used to have originally as a nice middle ground. From what we have seen from most customers today, medium utilization reserved instances are probably less interesting unless you're running exactly like 8 hours every day, nonstop, just running a fixed cycle. Then they make a lot of sense. And the kinds of, you get a ton of savings. I've already said that the key part from a capacity management perspective is that you're always getting a capacity. So there's companies out there, and I won't mention names, that run a particular size of infrastructure but want to carry a buffer, like in a traditional way. They might choose a mixture of heavy and light, where they'll reserve their core capacity as a heavy utilization RI, and their buffer they might utilize as a 25%, as a light utilization RI. It's cheaper, but it helps them save risk, but also make sure that the capacity is available to them. Also very useful if you're doing disaster recovery. Let's say you are a company that has a set of capacity in one data center in US East. And you want to make sure that you have some disaster capacity in US West. How do you make sure that when you need it, let's say there's a disaster in US East and everybody's moving to US West? How do you make sure that you get your capacity and you're not competing? You don't want to pay what you would for a heavy utilization RI, perhaps. Your utilization is not high enough. You can buy a light utilization RI. You still get the capacity when you need it. You're paying a little less because of your lower utilization. And that's partly because of these areas. This is an older chart, so it might be out of date. But at a certain utilization rate, it makes more sense to get a different instance type. So you can use that as you're thinking about planning. The third realm of this is spot instances. You've probably heard enough talks at this conference which talk about the fact that spot instances are instances where you bid in a market. You are not guaranteed you're not guaranteed that you'll get them unless your price is right. The way to think about spot instances is, what is this cycle worth to me? What's this data worth to me? And then you can provision a spot. You can say, okay, you know what? I have these background jobs that I would normally not run, but if the price is right, I'll run them. You can set your bid from them, and whenever that happens, they run. They're a great way of supplementing your core capacity or getting really, really cheap resources. I think Pinterest this morning talked about the fact that they essentially run their web server fleet on spot instances and then scale to on-demand or reserved when they need to. So, a typical user might, and spot instances come from our excess capacity. So a typical organization might use some form of reserved capacity, use on-demand to supplement it, and then use spot to lower costs or do background tasks that they may not normally do. We've seen this happen again more and more and more with a lot of companies as they get more comfortable with the spot instance model and the fact that these are asynchronous and your capacity can go away. This is just a funny way of thinking about spot instances where if you value a result, you want it really quickly, you probably don't want to use a spot. But if you want to do it cheaply and you want to make sure you can get a lot of capacity, it's a great lever you have to supplement what you do. And this is, as I said, this is a question you want to ask. What is the value of my data? What's the value of my compute cycle? How much am I willing to pay for it? How much am I willing to wait for it? So to go back, you have to ask yourself the right questions. The questions that NewCo might want to ask are, what is the baseline for each team? Again, to go back to where I was, that group in the front is using 50 instances all the time. The group in the middle is using 10 all the time, and the group in the top right is using 30. Identify that. Don't do it right away. It takes, sometimes in the cloud, you optimize your applications over time. You start using auto-scaling. You start trying to spread it across many zones. My recommendation usually is spend 2-3 months optimizing your app, making it work properly in EC2. Maybe you decide, hey, I don't want to use EC2 for my database layer. I'm going to use S3 right away, or I'm going to use DynamoDB or some other system. And that's going to reduce your compute capacity. That works very well. What is the length of a typical project? If you are running something that's going to be running all the time, or these short tasks, in the case of NewCo, they're project-based. They have to think through that. And are you using the right instance types? In this particular case, you can decide this NewCo is probably going to use a lot of cluster instances and a mixture of high CPU instances and potentially some high memory instances. So, what are we using? Why are we using it? And for how long are we using it? Definitely try and leverage spot instances. They really, really help supplement any capacity that you want to do, and adapt over time. Perhaps, I don't have a whiteboard here, one of the most common patterns of usage we've seen with AWS is people's usage will scale. This is how much they're paying. Then they'll get really efficient because they'll make some optimizations. They'll start using some other services. The usage will go down. Then they'll start scaling again, and they'll make the next level of optimization. And you have to think through that as well. The good news is that you have some very flexible levers that you can use to change instances, potentially move to a new capacity fleet, or just get more efficient. One really, really new, interesting feature that's happened is the reserved instance marketplace. In the past, when you had to buy a reserved instance, you wanted the low cost, but your project is probably just a couple of months, 3 months, you've figured it out. It may not make sense. In the reserved instance marketplace, you can actually go in and say, hey, I can buy a light utilization RI for that 1 month that I need my computing, and by the way, I can buy it at the low price of a reserved instance, but I get my capacity guarantees as well. So I don't have any picture of the sell side, but on the buy side, you can figure out, do I need it for 6 months? Do I need it for 1 month? Here are my options. I can make that acquisition as well. Right now, the market is still very young, so the quantities available are in the single digits or low double digits. Over a period of time, those quantities are going to get much, much larger, and it'll be an interesting use case for a lot of people thinking about capacity. We also have this very interesting feature called Trusted Advisor. How many people here are familiar with Trusted Advisor? No one. Trusted Advisor is a feature in our premium support offerings. It actually, if you go in, it's a dashboard. It tells you many, many things. It, for example, tells you if you have any ports open that you shouldn't. It gives you a warning saying, hey, you have 50 instances, and by the way, every port is open on half of them. You probably don't want to do that. So it gives you some really good warnings. One of the other checks it gives you is a cost optimization and reserved instance check. It tells you that, hey, you could probably save a lot of instances, money, by moving to reserved instances, but more importantly, it's telling you about your instance utilization. It's actually telling you for about half your fleet, you're underutilized. Maybe you want to shed some capacity because you're not using it. Or if you're using something like an instance with a lot of CPU and you're underutilized, you might want to go to an instance with less CPU. So it gives you that kind of information. I don't know if you can read here, but this one says about 147 out of 200 instances are currently underutilized, and if you terminate these underutilized instances or minimizing them, you could save about $723,000. Wow, not bad. That's a lot. I don't know what instances these are. So it gives you a lot of important information. So if those of you who are running mission-critical applications in the cloud, running production workloads, and have premium support, you can take good advantage of features like Trusted Advisor that give you really, really good information about how you're utilizing the capacity that you do have. And again, this is in monitoring. You can set up yourself. I hope, I would expect many people are, but just in case you're too busy, we have that check. So in the end, our goal is to remove constraints and unblock your people, and which is what we want to do, and make them very happy again. So let's make it real. This is our favorite company at this show, which is Netflix. This is a figure from a few years ago that I stole from Adrian Cockcroft. It shows all of their applications running at different. So they're running multiple applications. They're running everything from encoding to test and production, which is the blue line over there. They have a green line for their log analysis system. They all have different usage patterns. So let's look at their encoding runs. Their encoding runs happen when they get new content from a studio or they're releasing a new device. So let's say you're releasing, Netflix releases an iPhone application. They have to re-encode all their content because the formats for iOS are different from formats for the Xbox and the PlayStation or whatever devices they might have been on earlier. And lo and behold, in that time, they've got more content that they need to encode as well. So they need to spin up to probably that thing on the right, which is way more capacity than they typically use for a short period of time to do all that encoding. They always have some encoding to do because of adding content and getting backlogs. So this is very spiky. Spiky is a terminology that we use. If we see a customer who has a pattern like that, we call them very spiky. What is your long-term forecast? You just cannot predict whether you'll get more content when you're releasing your new device and how much encoding you might need to do. It's not easy. So our recommendation for something like that is to find the right instance type, find the most cost-effective instance type. In this case, you have to think through, am I using a C1? Am I using an M3? Or am I using a CC2? Netflix uses C1s. They found that they were the most cost-effective instance for their application. A lot of customers use CC2s because they just want juice. They're willing to pay a little extra price just to get the encoding done faster. We have a new instance type called the M3, which is actually pretty nice for encoding. So I suspect you'll see more of that being used in the coming months. So you have done that. You probably want to cover your baseline. They never get to 0. They can buy a light utilization RI to cover their baseline. They can supplement that with on-demand and spot instances to handle their spikes. I don't know if they do spot, but you could. And then you have your log analysis application. So that's for the encoding application, which is probably the most easy application to understand in an EC2 sense because it's up and down, it's elastic. You save a lot of money when you're not shutting servers off. The log analysis is daily usage. It's I think I heard somebody say that Netflix is a log analysis app that happens to stream movies as well. So there's a lot of usage. There's usage all the time. There are tremendous amounts of infrastructure behind it. There's occasional spikes when they need to spike up. And for that, especially for a lot of this analysis, so the BI side, they use Elastic MapReduce, ton of reserved instances, and they potentially can use Spot instances because EMR supports Spot for those bursts of capacity at a low cost when they need them. Works really well, and it's low cost. It's the way of thinking about capacity for a workload pattern like this. And for the test and production, that just goes up over a period of time. You'll find it's steady, it goes up, steady for a while. I'm sure if this extended out into later in 2010, it'd probably go up then as well. This is just a few weeks of capacity. So in this particular case, you're never going down, you're always adding. And depending on how far ahead you're looking, you can buy chunks of reserved instances. So your planning horizon changes. I think that's the biggest change. You're not thinking about this, 3 months, 4 months ahead of time. Yeah, I might need more capacity, or I think I'm definitely need more capacity. How much should I be getting? In fact, it could become weeks. Weeks is not bad. I think most companies will be very happy with weeks. But the idea is you want to get into days and some companies hours. But you want to predict a couple of days ahead of time. In fact, it happens a lot to us saying, hey, we're going to be featured on the App Store in 2 days. Can you increase my instance limit to 4,000? Sure, not a problem. So things like that. It lowers your risk because you're not thinking so far ahead and making mistakes. Anyone who's done forecasting of infrastructure knows that forecasting 6 months ahead is way worse than forecasting 2 months ahead, or even if you're doing 6 weeks to 2 weeks, you're off sometimes by an order of magnitude. So it may help in more accurate forecasting. You're much more efficient in your utilization. You're much more efficient in knowing, in predicting your costs as well, because you kind of know what you're going to use as opposed to 6 months down the line when you have no idea. So I wouldn't call them more accurate forecasts. I would just call them better forecasts because there is no such thing as an accurate forecast for anybody who's been involved with that. And the other key part of this is that it's global. You're no longer bound to a region. We have 9 regions, including AWS Cloud, 25 availability zones across those regions. Let's say you have to do an international expansion. I'm running in the US. I want to open up operations in Europe. You can, or wherever, I don't remember what my example says, you are in US East, and you want to expand into South America. It is quite simple to make an application that does that. And if anybody's gone to the Obama for America talks, you've already seen them do that, where when Hurricane Sandy was coming, they were able to quickly forklift their entire infrastructure from US East to US West in about a day. And it was pretty massive infrastructure. I already talked about disaster recovery a little bit. It's probably one of the lesser known examples. People are aware that AWS is really good for disaster recovery, but in most cases, you have to run something hot somewhere else to be able to do reasonable disaster recovery. In this case, you're running something completely cold. You're paying some reserved instance upfront fee. Remember, with light utilization reserved instances, you're not paying for usage if you're not running the instance. You've just paid that upfront fee. And almost about, well, over half your cost is the utilization cost, is the actual usage cost. So if you're not using them, you're saving a ton of money anyway. But they're always available to you if you need them. And the other case is just people who need geographic replication. For whatever reason, you want to run in 2 coasts. You're paranoid about, you want gazillion 9s, and you want to keep your databases running. You might be wanting to do that. And there you might want to run master, hot, probably heavy utilization reserved instances in both regions. Or keeping a hot spare. So the most common in the US is we've seen many customers running in US East and US West in recent times because they're so, just because they're paranoid. So I'm going to conclude this early. I know it's the last talk. I figured everybody would be tired. I know I am. I'll stay back for questions. So in conclusion, you have to think beyond the data center. You have to think beyond constraints of space. You are more interested in trying to think about what you need, when you need it, where you need it. Do you need it here? Do you need it in Europe? Do you have 2 teams? Each of them requires their own capacity. One's based in Singapore and one's based in New York. You want to, I don't know if anybody who works in your company looks like this guy, but you want to make them happy. I know nobody at Amazon looks like them. So again, thank you very much. Thank you for coming to reInvent. I think we're back here next year, 19th of November. Book your tickets. I know, it'll be fun. Thank you.